Lesson 6-3, Make Comparative Inferences About Populations. I can draw comparative inferences about two populations using median and interquartile range. Let's first look at the Explore It problem. Ella surveys a random sample of 20 7th graders about the number of siblings they have. The table shows the results of her survey. Part A, Model with Math. Draw a model to show how Ella can best display her data. In this case, we really have two choices. We can either create a dot plot or we can create a box plot. And we're going to explore both of those in this problem. First, for the dot plot, we need to create a number line that shows the range of the data. In this case, the smallest piece of data is 0, and the largest piece of data is 6. And we're going to take each data value from that table and put that data value on the dot plot. Pause the video to do that now, and then come back and check your answer. Here is what your dot plot should look like. Notice that each dot stands for one piece of data from the table. A dot plot is good if we need to see the shape of the data, if we need to see which data value represents the mode, which in this case is one sibling. And it's also good for picking out outliers. In this case, 6 is an outlier because only one person had 6 siblings, and that data piece is set away from the rest of the dot plot. Now I want you to try to create the box plot. Remember that the box plot shows us about the medians in the data set, in the first quartile, and in the third quartile. Try that and come back and check your answer. The box plot is a good visual representation, so we can quickly see that the number of siblings are concentrated between 1 and 2, and that the range of siblings goes from 0 to 6. In this case, the box plot also shows the variability of the data and also shows the medians of that entire data set. Remember, that's what we call that interquartile range. That's where we see the median of the entire data set. In this case, it's set at 1.5. So that's the midline here of that blue box. And then we also have the first quartile median, which is a 1, and the third quartile median, which is 2. And last but not least, let's focus on the math practices. What can you infer about the number of siblings that most 7th graders have? Well, in this case, by looking at both the dot plot and the box plot, you can infer that most 7th graders have either 1 or 2 siblings. The data in both models are clustered at 1 and 2. Finn and Jonah attend different middle schools. They compare the number of hours students at each school spend on homework each week. Finn and Jonah each conduct a random sample of 20 students who attend their schools and then list the data in order from least to greatest. What can Finn notice about the time spent on homework? So take a look at the data in the tables. Step 1 says to display the two data sets in box plots. By creating box plots, we can easily compare those two data sets side by side. In this case, Finn's data set begins at 1, that's the beginning number of your range, and ends at 11. In Jonah's data set, Jonah's also begins at 1 and ends at 11. But do you notice anything different about those two data sets? In Finn's data set, most of those hours are concentrated between 1 and 9, and then 11 is kind of the outlier. In Jonah's school, in his data set, most of the data values are concentrated between 5 and 11, but there is one piece of data at 1. That also is an outlier. Notice in the table that I drew a blue line where the median occurs in both data sets. Since these data are already organized from least to greatest, remember we find the median by looking for that middle point. In this case, the middle point for Finn's data set is a 5 in both cases, so the median is 5. In Jonah's school, the data set, the median is between 6 and 8, so in his data set, the median is what's between those two, which is 7. Next, we need to look for the first quartile median, which tells us where the box begins on our box plot. In this case, for Finn's school, that first quartile median is between the 3 and the 4, or 3.5. And for Jonah's school, it's between 5 and 6, or 5.5. Remember that we took the first half of that data and we split that in half again. So Jonah's box begins at 5.5, and Finn's box begins at 3.5. Last, to get the third quartile, we need to find the median of the second half of the data. So for Finn's school, that second half of the data is between the 6 and the 7, which is why it's 6.5. That's this piece right here. And for Jonah's school, the two median numbers are 8, which means the median of that data set is also 8. So that tells us where those end boxes are. And remember, the blue line here tells us the median of the entire data set. So when we're looking at the box, we see the end points, which are where our data sets begin and end. And for both Jonah and Finn, they begin at 1 and end at 11. But it's the shape of those boxes and the spread of that data that helps us make those inferences. So step 2 says to use the box plots to compare the data sets. The line for the median of Jonah's data set is set to the right of the line of the median for Finn's data set. So Finn can say that the median of Jonah's data set is greater. That median line is farther to the right than Finn's. The box for Finn's data set is longer than the box for Jonah's data set. So Finn can say his data is more spread out or has greater variability. Okay, so Finn's data set is more spread. And that means he has greater variability. And in this problem, the median best describes the data because both data sets have outliers. What we can also notice is that at Finn's school, the median number of hours of homework is 5, and it ranges basically between 3.5 and 6.5 hours. But at Jonah's school, the median is 7, and the range of those homework hours is between 5.5 and 8. So what we also might be able to conclude is that students at Jonah's school spend more time on homework than students at Finn's school. Now let's take a look at the triad. Kono gathers the heights of a random sample of 6th graders and 7th graders and displays the data in box plots. What can he say about the two data sets? So the first thing that I want you to notice and look at are where the boxes are and how big those boxes are compared to each other. We also can notice the median of each data set. Let me try that median again here. okay? And we are going to be making some inferences here based on that information. So what can you say about those two data sets? In this problem, what we might notice is that the median of the 7th grade sample is greater than the median of the 6th grade sample. In this case, the median of the 7th grade sample is about 63 inches, while the median of the 6th grade sample is about 62 inches. We also notice that the 7th grade sample has greater variability, and you can see that here when you look at the box plot, because that data is more spread out than the 6th grade sample. The box that represents your first quartile, your median, and your third quartile is much larger than the box for 6th grade. So we do notice that it does have greater variability. Now let's take a look at example 2. Let's draw inferences using median and interquartile range. So back to Finn and Jonah and their assessment of homework hours per week. We notice that in Finn's data set, his first quartile value was 3.5, his median was 5, his third quartile was 6.5, and his interquartile range is 3. Now how did they get 3? Remember that the range is the difference. So we're looking for the difference between the third quartile and the first quartile. So 6.5 take away 3.5 is where that interquartile range 3 comes from. In Jonah's data set, his first quartile was 5.5 with a median of 7 and the third quartile of 8, making his interquartile range 2.5. Again, that comes from the difference between 8 and 5.5. So what we can notice here is not only is the median of Jonah's data set greater, the students at Jonah's school generally spend more hours on homework each week than students at Finn's school. But what we also might notice is something about that interquartile range. In Finn's data set, that is greater. So there is greater variability or spread in the number of hours that students in Finn's school spend on homework. In other words, it's harder to make a conclusion about the number of hours in Finn's data set spent on homework because the data values are very spread out. Now take a look at example 3. We're going to draw more inferences using measures of center and variability. This time we're going to be talking about the growth of plants. Mr. Bunsen had students grow the same type of plant in 2 different rooms to test the growing conditions. The box plots show the heights of all the plants after 3 weeks. How do the 2 populations compare? What inferences can be drawn? We'll take a look at room 7D and room 7G. The box plots here show us that 50% of all the plants in room 7D are between 8 and 14 inches tall. That's where the box is, with an interquartile range of 6, because remember, 14 take away 8 equals 6. We also notice that the median height here is the same for both rooms at 12. In room 7G, 50% of the plants are between 10 and 16 inches tall, which also gives an interquartile range of 6. While the median heights of the plants are the same, the plants in room 7G are generally taller. How do I know that? We can infer that because look at where the boxes are. The box for room 7G is further to the right than the box for room 7D. So what we can infer here is that the growing conditions in room 7G are more favorable for plant growth than in room 7D, because those plants in general were growing taller. Now let's look at the try it question. A local recreation center offers a drop-in exercise class in the morning and in the evening. The attendance data for each class over the first month is shown in the box plots at the right. What can you infer about the class attendance? Well, when I examine the box plots, what I notice is that the box for the morning class and the box for the evening class don't line up. So clearly there is a preference over drop-ins for the evening class, since that box is further to the right than the box for the morning class. Remember, those boxes represent 50% of the data for each set. So because those boxes represent half of the data set, then our inference is usually more valid.